Good morning, students. As I'm discussing that hydrogen spectrum, spectrum is what? When white light is made up of all the colors, visible spectrum, we can see. Basically, spectrum, when we see, this is passing from a prism. So hydrogen spectrum, if I'm going for hydrogen spectrum, basically before hydrogen spectrum, so we should know that if light is not white, then what happens? So if that any energy hitting a gas, we know that by absorbing that energy within the gas, that different types of light can emit. That is the basic of that emission spectra. So it is also happening when white light passes through the prism. So we are having basically from prism, when white light pass, we are having continuous spectrum, and when hydrogen gas pass, that is the main discussion topic here, we will have discrete spectrum. Okay, so continuous spectrum when white light passes through prism, and when the hydrogen gas passes through prism, we are having discrete spectrum. Some of that is called, that is emission spectrum, some of that is called that absorption spectrum. And that's why when in my age, when we are doing that in my graduation class, when we are discussing regard when we are that experimenting in lab, optics lab, basically on spectrum analysis, we are having hydrogen vapor lamp or mercury vapor lamp, because they can produce discrete spectrum, and if we they can produce discrete spectrum, that is easy to calculate the wavelength. So atomic spectrum is also called the fingerprints of atom. Means from that atomic spectrum we can get that the structure of atom also. So hydrogen spectrum was first systematically studied by Balmer. It consists of discrete bright lines on a dark background. See, dark background, discrete bright lines. If you see dark background, discrete bright lines, we are getting in that hydrogen spectrum. So basically these are named as H alpha, H beta, H gamma, and so on. These lines is going from one end to the other. The brightness of the separation between them decrease regularly. So as long as we are proceeding to the higher, lower order, that brightness slowly decreases, and higher order brightness increases. So these lines are members in the series are called that Balmer series, because Balmer first that investigate on the hydrogen spectrum. So Balmer in 1885 found that the wavelength of the lines represented by the following empirical formula. What following empirical formula? Already I am showing you first. That empirical formula is what? That is R into, that R is what? Today I said that is the Rydberg's constant, that is into 1 by n1 square minus a. Given that nu bar means that is the wave number, nu is the frequency, bar means the wave number, that is that 1 by lambda. They are discussing on that, and from where we are getting that? We are getting that from Bohr energy calculation. So wave number in different spectral lines can be calculated corresponding to what? N1 and N2. N1 and N2 are the different orbit number. So Bohr explained that hydrogen spectrum. How Bohr explained that when current is passed through the hydrogen gas, the discharge tube at low pressure, the molecules of the hydrogen gas break into atom. So hydrogen gas break into atoms, electric discharge happening within the hydrogen atom. So right now that hydrogen molecules break into two hydrogen atoms. These atoms absorb energy from electric spark. Electric spark means basically that energy which is passes through that actually we can say that electric discharge tube. So they absorb the energy. So the electron in hydrogen atom excited from where? High energy level. So this is the ground state. So from ground state they are excited to the higher energy level, and energy they are getting from that outside discharge electricity, they are getting energy. The higher energy orbits through which electrons migrate depends upon the atom of energy absorbed by the electron. As I said earlier, abruptly any energy not possible. For particular, suppose hydrogen, we are having a specific energy that can be absorbed by that hydrogen. So what is happening, these excited electrons being unstable, so obviously if you are having extra energy, so you are right now from stable to unstable. In the ground state you was in the more stable situation, so from that stable to unstable you are right now. So what you will obviously you are having a intention to again come to the ground state. So if you are having an intention to again come to the ground state, so obviously you will release energy in terms of photons. So electrons may come to the lowest energy level, and this way they emit energy, they are absorbed. So let's go for that. So this is what hydrogen gas tube. So from that voltage discharge is there. So hydrogen gas, due to that voltage discharge here from that slit, just in that interference pattern, so through that slit the spectrum is coming, or the inner light is coming, and when the radiant energy falls in the prism, after prism we are having a photographic plate. So photographic plate, back photographic plate, we are getting discrete hydrogen line spectrum, which is looks like this, as you can see that violet, purple, little bit of violet, then sky, and this was the yellow. So the wave number, already we know that different spectral series are produced depending upon the excited ground energy level of the atom. Already we know, have done this one. So hydrogen spectrum, if I see shown you carefully, so this is that what lower energy level. So violet, this is what higher energy level. This is the blue green structure, we are getting 3, blue, green, and then red. So this is the hydrogen bomber series. So after that we are having what that equation what we are discussing, that is that Rydberg's constant into 1 by n1 square minus n2 square. So this equation is called wave number equation. So first we will discuss that what Lehman series. What is Lehman series? The spectral lines in Lehman series are explained by considering that electrons falls back to ground state, or might be any excited level, but when it falls to that ground level, we are calling that spectral band as Lehman series. So that is the Lehman series. So next one is let's see, Lehman series basically that ultraviolet region. Explain the ultraviolet region. So any state, you might be at n equal to infinity, you might be at n equal to 7, you might be at n equal to 6, might be at n equal to 5, you are coming to the ground state, which is n equal to 1, and which is also called it is called that Lehman series.